So far, we've used the periodic table to both figure out how many protons, neutrons, and electrons an atom has, as well as figure out the electron structure for a given element. We also saw that the columns of the periodic table tell us what the charge or number of valence electrons are for a given atom, but what else can we learn from the table? Well, before we look at the specific parts, there are two terms that we need to know. First, a group on the periodic table is a column. So whenever I refer to a specific group on the periodic table, I'm referring to a column. And remember that elements in the same group have similar properties. So if you find two elements in the same group, it is very likely that they share some properties. Now, we also have the rows on the periodic table. The rows on the periodic table are known as periods. And the periods are the rows, and this is why it's called the periodic table. So we have the groups, and we have the periods. Periods don't really share any properties in common, so we're going to mostly focus on groups. It is also important to note that we have 7 periods on the periodic table, and we have 18 groups. So every column, even the ones in the middle here, count as a group, so we have 18 groups, and I'll show those labels. So here we go. This is the table showing all 18 groups on the periodic table and all of the 7 periods. And you might be asking yourself, well, what about these elements at the bottom? Why don't we say there are 9 periods? Well, if you look, these are actually matched up. We have element 56, and here's element 57. Here's element 71, here's element 72. So what this shows us is that these elements actually belong right here on the table. But why are they down there? So this video is going to show us exactly why. So here's our periodic table, just like we normally see it. Now, if I put those elements where they should be on the table, notice that our table gets very, very wide. This is too wide to fit on most normal pieces of paper and still be able to read any of the information on it. So we keep it in this condensed form. We pull these 2 periods out from the rest of the table, even though they are still period 6 and period 7, and it's just to save space. No special chemistry reason or scientific reason, it is just to save space on a piece of paper. Now we're going to start looking at some of the big important groups on the periodic table. So how can we classify the elements? So if you look at the table that I have above, you'll see that I have this section of elements highlighted in different colors. And again, this is from ptable.com. And all of these elements, you can see the vast majority of elements are known as metals. So metals are mostly on the left side of the periodic table, and most of the elements are classified as metals. So what are metals? How do we know something's a metal versus a non-metal? So what are the properties of metals? Well, the properties of metals are those things that you would think of when you think of a metal. Well, the first thing when you look at metal is that you notice that metals are shiny, which just means that they reflect light. So metals tend to be very shiny. Well, what else do you think of when you think of a metal? Well, metals tend to be solid at room temperature. Almost every single metal, if we're at room temperature, about 25 degrees Celsius, about 72 or so degrees Fahrenheit, is going to be a solid. The only exception is mercury, which is a liquid at room temperature. So all the metals that we normally use, or actually all the metals on the periodic table, are going to be solid, with the exception of mercury. And you can see mercury right here in this image. It's in this vial because if not, it would flow away out of the image. What else do metals have as properties? Well, they are good conductors. And a conductor just means a carrier or transmitter of electricity and heat. And this is a really easy thing to show. So you're probably sitting in a chair right now, or you're somewhere where there's metal and something that's non-metal around you. Touch the metal. It should feel kind of cold. Now touch whatever object you have near you that is not made of metal. It's going to feel a lot less cold. Now, both objects should be at the same temperature. They're in the same area. They've been sitting out. Maybe they're at room temperature. But why does the metal feel colder? Well, the metal is better at absorbing heat from you, given off by you, than whatever you have that is not made of metal. So metals transmit heat. Well, metals transmit electricity too. Just think about your electronics. What are the wires in your electronics made of? Well, they're made out of metals. Metals carry electricity very, very well. Another properties of metals is that they tend to be malleable. And all that malleable means is bendable. And we can see this here in the picture where we have copper and it's been bent into this loop. Also, we have platinum, which is actually folded on itself. So metals are malleable, which means bendable. And metals are also ductile. And ductile means can be made into a wire. So metals tend to have the ability to be made very, very thin, almost actually like this copper right here. And then we have one final property. We've actually talked about this before. When metal atoms become ions, they lose electrons and become positively charged. So metals, whenever they become ions to gain their full octet, are going to lose electrons and become positively charged. So now that we've talked about metals and the majority of the periodic table, let's look at what's left. So the right side of the periodic table, as well as hydrogen, which is over here, and again, hydrogen is just located over here. Even though it's not a metal, it has one valence electron, so it reacts like many of these metals. But it is actually considered a nonmetal, like this right side of the periodic table. So nonmetals are located on the right side of the periodic table. And let's look at some properties of these nonmetals. So what you can actually see in this first picture is that nonmetals are not all solids. So here we have chlorine gas here we have bromine liquid, and here we have iodine solid. And also here is some carbon solid. So the nonmetals include elements that are solids, liquids, or gases, which is very different from the metals, which are pretty much all solid. So we have all three phases are represented in the nonmetals. You'll also notice that nonmetals are not shiny. They are dull. So one way you can tell a metal from a nonmetal is if it's very shiny, it will be a metal. If it's dull, it does not reflect light very well, it will be a nonmetal. They are also good insulators. And this means that they do not carry electricity or heat very well. So if you wanted to protect something from heat or protect something from electricity, you would use a nonmetal, something that does not carry electricity or heat, an insulator. And lastly, if you go to bend a nonmetal, you will notice that they are brittle. So they break apart when force is applied. So unlike a metal that's going to change its shape, it's going to bend when you put force on it, nonmetals are actually going to break apart. So here's an example. Here's a block of carbon, and when force is applied, it crumbles, it breaks into these little pieces. It does not just change its shape. So nonmetals are brittle. They're basically the opposites of metals if you look at all their properties. So you may have noticed that there's actually a section of the periodic table that we haven't talked about yet. The elements that we haven't yet talked about are the ones in between the metals and the nonmetals. So this left side of the table we said were the metals, this right side of the table were the nonmetals. So this last group falls right in between those two groups. What we often draw on our periodic tables is a staircase, just like this. And what we say is that most of the elements that are bordered on two sides by this staircase, with the exception of aluminum, are part of this third and final major group on the periodic table. And these are known as the metalloids. And the metalloids are located in between the metals and the nonmetals on the periodic table. And what property do these things have? Well, metalloids, because they are in between metals and nonmetals, will have some properties of metals and some properties of nonmetals. So, some are shiny, some are dull. Some are malleable, and some are brittle. And their properties, they may not be as bendable, as malleable as the metals, but they're not as brittle as the nonmetals, so they fall in between. And the most important property of these metalloids, and these elements may actually be some of the most important elements we use today because of this property, is they are semiconductors. Well, what does semiconductor mean? Well, it means under some conditions, and these can be electrical conditions, temperature conditions. Under some conditions, these elements will conduct electricity, and under other conditions, they behave as insulators. Or I shouldn't say behave, they're not humans, they act as insulators. Well, why is this property so important? Well, if something can conduct electricity sometimes and doesn't at other times, it can act like an on-off switch. And what are modern-day electronics? Well, they pretty much all are on and off switch. Thousands and thousands and thousands of on and off switches. So the chips that we use in our electronic devices use metals such as silicon, metalloids, in order to work. So sometimes they'll turn on, they'll conduct electricity, and sometimes under other conditions they'll turn off. They won't conduct electricity. If it's on, it's a 1. If it's off, it's a 0, and you have binary code. So those are all the major categories of the periodic table. Next, we're going to talk about the columns, the groups of the periodic tables, in a little bit more detail.